This is Honors Algebra 2 Pre-Calculus. We're doing section 9.6 in Pre-Calculus, which is counting principles. So let's talk about E5. In how many ways can you arrange, all right, so part A, the letters A, B, C, D, E, F. Okay, so there are 1, 2, 3, 4, 5, 6 letters, right? If I want to arrange 6 distinct items, there are 6 factorial ways to do it. And you can either do that by writing out 6 times 5 times 4 times 3 times 2 times 1, or you can just think, hey, I get it, that's 6 factorial. So I don't care if you do it like this, right? If you need to actually like write it out in your brain, right? Like the first option, you have 6 letters, then 5 letters, then 4, then 3, then 2, then 1. Or if you want to write it as 6 factorial, either way, it's a 720, which you can get by putting 6 factorial in your calculator. As a reminder, the way you do factorial in your calculator, right? So you can do 6, right? And then you're going to go math over to probability and pick 4. 6 factorial. So how many ways can you arrange the letters in the word math? Again, arrange means that that order matters, right? So there are 4 letters, so you can either think about that as 4 times 3 times 2 times 1, right? Or you can think about it as 4 factorial. It doesn't matter which. And either way, it's a 24. So the last one's a little bit different. So how many ways can you arrange the top 3 finishers in a 10-horse race? So there are 2 ways to get here. You can either use that NPR formula, or you can walk through another bit of logic about how it works. So here's the thing about this. You have 3 spots, right? So one way to do this is logically, right? How many horses could finish in the first spot? Well, there are 10 horses, so all 10 of them could. But once somebody finishes first, now there's only 9 options to finish second. And then for the third spot, there's only 8 options. So you get 10 times 9 times 8, which is 720, right? That's how many ways the top 3 finishers could happen in a 10-person horse race, or a 10-horse race, not 10 people. Anyway, you get my point. There are probably people on the horses. But there's another way to think about that. The other way to think about it is using that NPR logic, right? So the other way to think about it is as 10p3, right? And if you did that, the formula says that that's 10 factorial over 10 minus 3 factorial. Well, that would be a 10 times a 9 times an 8 times a 7 factorial all on top of a 7 factorial, and you can see that I still get 10 times 9 times 8, which is the 720. So again, you can either think about this logically, or you could use that NPR, because you're taking 10 horses and you're picking 3 of them in order. NPR, so 10p3. Anyway, either of those would work.